Okay, the purpose of this little lecture is to give you the keys to doing what are called truth trees. Truth trees are a way to take a pre-symbolized argument, an argument that you've already symbolized, put into our symbolic form, and automatically, like turning a crank and determining if the argument is valid or not. What I'm going to do right now is just give you some information. I want you to watch this video, then go on to watch a few other of the examples of constructing truth trees, and then come back and relook at this one again to see if it makes more sense. Then go watch a few more of the examples, then come back to this one again to see if it makes sense. That flipping back and forth and watching it over and over will probably drive you insane, but it will also help you to figure out how to do truth trees. What we're doing is we're testing validity with these truth trees. An argument is valid if it is impossible for the premises to be true at the same time that the conclusion is false. The way that a truth tree lets us test for validity is through the idea or the concept of consistency. A set of statements is consistent if all of them can be true at the same time. So what we do is we take an argument with the premises and the conclusion, and we are going to negate the conclusion. We're going to list the premises as asserted as true, and we're going to negate or put a tilde on the conclusion. That's essentially making the conclusion false. So we're going to check to see if it's possible for, I spelled that wrong, oh how funny. We're going to check to see if it's possible for the premises and the negation of the conclusion to all be true at the same time, if those statements are consistent. If it's possible for the assertion of the premises as true and the negation or denial of the conclusion to be true at the same time, then we've shown that the premises can be true at the same time as the conclusion is false. We've shown the argument to be invalid. How are we going to do that? One more time. We're going to list the premises as true, just rewrite them exactly as they are. And then we're going to take the conclusion, whatever it is, and we're going to put a big tilde on it. We're going to negate that conclusion. Remember, if the conclusion is the prince is bald or P, remember what happens if I negate P. If P is true, then tilde P would be false. So in other words, what I do when I slap the tilde on that conclusion is I'm making that conclusion false. So I'm going to check to see if the assertion of the premises as true and the negation of the conclusion, making it false, if those statements can be true at the same time. If they can't all be true at the same time, then I've shown that the argument is indeed invalid because it's possible for the premises to be true when the conclusion is false. So I list the premises as true, and then I make the conclusion false, and then all I do from that point forward is I translate under what conditions each of those above statements, each of the statements in the set that we're testing, I translate those into what makes those, the circumstances that makes those statements true. For example, suppose I've got one of my premises is, excuse me, tilde tilde P. I know that it is not the case that P is the exact same thing as saying P. So whenever I see a statement that is double negated, I'm automatically going to write beneath that statement the simple statement without the double negation. So under what conditions would a conjunction be true? A conjunction is going to be true when both conjuncts are true. We already know that from the rule. A conjunction is true when both conjuncts are true. So in order for this statement to be true, both of those simple statements must be true. And I'm going to write in a direct line beneath that statement both of the simple statements there. As you work through the truth tree, again, this will make more sense when you look at the examples that are coming up. When you make this true by listing its constitutive statements, we're breaking everything down to its simple level as you're working through the truth tree. And we're going to say that this doesn't branch. We're going to say this stacks, because I'm going to stack P and Q beneath the statement P and Q. What it takes for the statement P and Q to be true is both P and Q must be true at the same time, in the same stalk. So under what conditions would the statement P or Q be true? Well, we know it's the inclusive use of the disjunction. So this statement will be true in three ways. It'll be true when P is true, it'll be true when Q is true, or it will be true when both of them are true. But we can really say that there are two conditions that will make this statement true. This statement will be true either when P is true or Q is true. Now, why did I do this instead of this? Here we're saying that the tree will branch. What that means is that this statement will be true when either P is true or when Q is true. So the tree is branched. Either one of these two conditions will make that statement true. But here what we're saying is that the conjunction P and Q is only going to be true when both P and Q are true. Both of these must be true in order for this to be true. So when both these conditions are true, we're in a straight line. When it's either one condition or the other, we branch. So with the conditional statement, under what conditions will the hypothetical statement be true? Well, we know that a hypothetical statement is only false when the antecedent is true and the consequent is false. So what that means is it's going to be true under all other circumstances. So how can we boil this down to two conditions? Under what two circumstances will the conditional statement be true? Well, if this statement is going to be false when the antecedent is true and the consequent is false, we know right away that if the antecedent is false, that statement's going to have to be true. And we know if the consequent is true, that statement's going to have to be true. So this statement will be true when either the antecedent is false or the consequent is true. Notice if both of those are the case, we've still met that. If the antecedent is false and the consequent is true, we've met that by saying that the antecedent is false. So ultimately, those are the two cases that it would take to make that statement true. So whenever you see a conditional statement on the truth tree, you'll write below that, you're going to branch, and you're going to say that the antecedent is false and the consequent is true. What about the biconditional? Well, remember the biconditional is sort of an odd bird here. It's true in two ways, and it's false in two ways. It's true when P and Q have the same truth value. So notice P and Q will have the same truth value when they're both true, and P and Q will have the same truth value when they're both false. So this will likewise branch, and this statement will be true when P is true and Q is true, and this statement will also be true when P is false and when Q is false. Now let's move down to our next row that I've got written here. Under what conditions would a negated conjunction be true? Well, notice this. The question we're asking is, under what conditions would this whole statement be true? Well, this whole statement will be true when that conjunction is false. That's our rule for the tilde P. If P is true, then tilde P is false. But we're asking under what conditions would tilde P be true? It will be true when the statement to which it's appended is false. So this whole statement will be true when the statement within the brackets is false. So under what circumstances will P and Q be false? P and Q will be false when either P is false or Q is false. So let me repeat this. This whole statement, the negated conjunction, will be true. This whole statement will be true when either the first conjunct is false or the second conjunct is false. So under what conditions would this be true? This whole statement, the negated disjunction, would be true when the disjunct is false. So under what conditions would a disjunction be false? A disjunction is false when both disjuncts are false. So notice here, I stack, I don't branch. What it takes to make this whole statement true is for both P and Q to be false at the same time. So I stack, I don't branch. So under what conditions would a negated conditional be true? Well, once again, this whole statement will be true when this statement is false. And now this is easy. When is a conditional statement false? When the antecedent is true and the consequent is false at the same time. So we stack. This whole statement will be true when this statement is false. And a conditional statement is false when the antecedent is true and the consequent is false. Finally, under what conditions will the biconditional be false? Under what conditions will this whole statement, the negated biconditional, be true? Well, we know, again, the biconditional is the odd bird. This whole statement will be false when this whole statement will be true, when the biconditional itself is false. And a biconditional is false when its constitutive statements have opposing truth values. So this will be false when either P is true and Q is false, or when P is false and Q is true. Now, when you construct a truth tree, just to wrap up really quickly, you list the assertion of the premises, the denial of the conclusion, and you're testing that set of statements to see if they're consistent. Once you list the set of premises asserted as true and the conclusion is false, then all you do is turn the crank and reinterpret under what conditions are those statements true. You're never changing the truth values. You're just rewriting what makes them true. And that's what we've just done here. Not P is true when P is true. P and Q is true when both P and Q are true at the same time in the same row. P or Q is true when either P is true or Q is true, it branches. If P then Q is true when either the antecedent is false or the consequent is true. And I'll let you fill through with the rest. This is going to seem confusing after listening to this first little mini lecture. What I want you to do is go look at some of the samples that I've got listed here where I actually work out some truth trees. I list those. I work my way through them and explain them. Then come back to this one again. Okay? Do that and then let me know on the discussion board if you have any questions. I'll be glad to help. Good luck.